So in this lesson, we are going to learn how to put a quadratic equation into vertex form. And so the learning target is I can put a quadratic equation into vertex form by completing the square. So we're going to kind of review the completing the square process, and that's kind of how we're going to use that to put our equations into vertex form. So the warm-up is to use your graphing calculator in the vertex of the following equations. So in my calculator, I'm just going to type number 1 as I see it. So I'll go to y equals, clear what's there. I'll put parentheses x plus 3 squared. Oops. Squared. Oops. Let me do that again. X plus 3 squared. And then minus 5. And so the vertex, if you remember, is the highest or the lowest point. It's not and the lowest point. It's either the highest or lowest. Or you could say it's the turning point. So that's from last unit. Okay. So if I go to this graph, I'll see a parabola, and the vertex is the point where it's the turning point. So in this case, it's the lowest point. So I'm going to go to my table so I can see specifically what that point is. So if you're in a quadratic, you're looking for the symmetry in the table, right? So the parabola will have symmetry, and if you look, you can see that my my y values start to have symmetry right here. And the lowest y value is at -3, the y value of -5. So the vertex for this parabola is -3, -5. And if you look, that looks very similar to my numbers up here. Okay, that's not a coincidence. That's why we call we put this is a quadratic in vertex form, and that's because it tells us what our vertex is. So again, we'll do the same thing to kind of see if we can see a pattern. So for number 2, I'm going to put that parabola in there. And I'm going to look, the parabola looks like that. So my vertex is right there. So I'm going to kind of try to find the symmetry in my table. And my symmetry happens right here, and the lowest point is -1, 6. Oops, I think I typed this in wrong. I'm sorry, this should be minus. So parabola should be there, and the lowest point will be 1, 6. So that's my vertex for that equation. So how can you find the vertex without using your calculator? What do you notice about the equations? So the x value is opposite of what's in the parentheses, right? It was a +3 in the parentheses, but our x value ended up being negative, and it was negative here, but my x value ended up being positive. So the x value is the opposite sign. The y value, though, is the same. So the x value is inside the parentheses, and the y value is on the outside. So a quadratic equation is in vertex form if your equation looks like this, where the point hk is in vertex form. So that's just saying whatever number is here and whatever number is here is your vertex, right? And I'm taking the opposite. This h is negative here, but it ends up being positive in my actual point. Okay, so here you're just going to kind of look using your calculator or without using your calculator, find the vertex. So for example, for this one, I know my x value will be opposite of what's in the parentheses, so -5, and it will be the same as what's on the end. Okay, so that's all you're really doing. If you look, oh, there looks like there's a typo here. This should be y -3. And here. So if you look at 5 and 6, before you tell the vertex, you need to get this y by itself. So I might subtract 2 on both sides here. So that would be x plus 1 squared minus 2. So that means my vertex is opposite what's inside the parentheses, -1, and then the same there. So my vertex ends up being -1, -2. And so same with here. I'll get the y by itself, and then I can tell the vertex. Okay, so that's part 1. That's basic. So if you want to, pause the video and finish this up right now. Okay. The next part of this is, what if I have an equation in standard form and I want to change it into vertex form? How do I do that? So we do that by completing the square. Okay. So the first step is to get your C value. So number one is going to be to move C value. And this just helps to the other side. This just helps kind of be able to see what your C value needs to be. So that means I'm going to take 8, I'm going to add 8 to both sides. So I can see what I need to add to be my C value here to make it a perfect square trinomial. Remember, when we complete the square, we're trying to find the perfect square trinomial. So I'm going to take my B value, which in this case is -2. I'm going to take half of that number, which is -1. And then I'm going to square -1. That gets me +1. So I need this number here to be 1. So if I add 1 to this side, I definitely have to add 1 to that side. So this side ends up being y plus 9 equals x squared minus 2x plus 1. Okay, and then I'm just going to factor the side that has the quadratic or the perfect square trinomial. So I know that that's going to be x minus 1 times x minus 1. -1 times -1 is +1, and -1 plus -1 is -2. And the right side will, or the left side will just stay the same. I can condense this to be y plus 9 equals x minus 1 squared. My last step will be to get y by itself. So this equation in vertex form is y equals x minus 1 squared minus 9. So that means my vertex here would be 1, -9. Because remember, it's opposite of what's in the parentheses, and the y value is the same. So that is my equation in vertex form, and I was able to tell my vertex right from just doing that. So to do this, it's the same process as completing the square. The only difference is you just have a y here, which you just kind of leave until the end. You want to get it by itself so you can get your vertex. So the second step of this would be to complete square. So that's like taking the b value. That's this part. Complete the square. Add the number to both sides. Factor the trinomial. And then your last step is to get y by itself. Okay, so as you're working through this, these might help you to remember the steps of completing the square. Okay, so for example, in number 1, this is the practice here. So if you feel comfortable, go ahead and complete the practice. You can stop the video here. If you'd like to see one more example, I will do number 1. Okay, so my first step is to move the c value to the other side. So I'm going to get rid of this -5 by adding 5 to both sides. So I have y plus 5 equals x squared plus 4x. And so now is where I will complete the square. So I need my b value, which is 4. I need to take half of that, which is 2. And then I need to square 2 to get what my c value should be. So it should be 4. So I'm going to add 4 to this side. Whatever I do to one side, I have to do to the other. So I'll add 4 to the other side. That will make y plus 9. Now I can factor this side. Factors of 4 that add to be 4x plus 2. They should be the same. So that becomes y plus 9 is equal to x plus 2 squared. And then my last step is to get y by itself. So I'm going to subtract 9 from both sides. So I'll have y equals x plus 2 squared minus 9. And then my vertex is -2, -9. Remember, it's always opposite what's in here, and then I take that y value there. So there's the vertex in vertex form and the equation in vertex form. Say you weren't sure you were right, you could type in the original equation and see what the vertex is and know that you have that will be your right answer. So you know that this will have a vertex of -2, not -9, so you'll know what your equation should look like after you know what the vertex is. You do have to be able to do this, though, to show that you're completing the square. Sometimes they'll ask you to put your equation in vertex form by completing the square, so you do have to know that process. So your job is just to finish the rest of the practice.